and I'll present to you my thesis projects during which I combine acoustics and accelerometry data to assess killer whales' interactions with longline fisheries in southeastern Australia. So in the past decades, the expansion of human activity has led to an increased number of negative interactions between human and animals. You have several examples here of competition for space, but also resources around the world, with the specific example of the depredation. So what is depredation? It's a competition for resources between human and animals, during which the predators are actually feeding on a prey, which was unintentionally supplied by human activities. So that includes livestock husbandry, but also fishing. So it's a phenomenon that was well studied on land, with large carnivores, which are actually substantially impacting the livestock around the world. But it has been more and more observed in oceans lately, and it involves the competition for resources between fishers and various species of large predators, including sharks, for example, but also toothed whales that we call odontocetes, and which are mainly represented in that case by sperm whales and killer whales. So this study focused on the level of interactions between killer whales and blue-eyed trevalla in the demersal longline fisheries in the southeastern Australian exclusive economic zone that you can see located here on the map. So what we know about this interaction, well, we don't know much because the killer whales population is not really well known locally. They live quite far offshore, so it's a bit hard to study and observe them. And regarding the blue-eyed trevallas, it's a species of toothfish that lives at the edge of the continental shelf between 200 and 800 meter depth, and which possesses a high commercial value on the fish market in the southeastern Australia, in Australia in general, sorry. And that's why the local fishing industry is really important, it's really profitable for the fishers down there. The very first assessment of the depredation rate was made in 2018 by Tixinal, and it gave us a rate between 16 and 85%, which is quite broad, and it's a percentage of interaction for all fishing day per year. It's based on a 6-year study, which only relies on surface observations, as did most of the depredation study before, which raises the question of a potential underestimation of the depredation rate with all the economic and ecological impacts involved. So what we did in this study, we used a novel approach in order to assess the depredation rate and to tackle the potential sources of underestimation by using a combination of acoustics and accelerometry data. So with the acoustics, we were able to detect the presence of killer whales while being underwater at all time during the fishing operation. And we compare all this detection rate with the visual detections made by the observers. The accelerometer were recording the differences in the vibration of the line on the hooks, which were characteristic of fish hits, fish captures, but also potential suspect depredation rate, because when the killer whales are removing the fish from the hook, it makes the line vibrate. So we then examine the timing and depth of these fish captures during the fishing process, and combine these results with acoustic data to isolate the potential depredation events and to compare the timing and depth with those of the fish captures. Globally, this study aimed at developing mitigation strategy by improving fishing practice locally. So the data collection was performed previously to my thesis on board 2 vessels during 2 fishing seasons, between 2018 and 2020. You have all the fishing trips of both years of study represented here on the map. We collected data during longline fishing operations. We are all divided in 3 phases, starting with the setting, during which the line is deployed in the water, as presented here. And once all the hooks have reached the seafloor of the hooks of the main line, the soaking starts, and it usually lasts between 6 and 7 hours. At that time, the boat is not on site anymore, and it will come back for the start of the hauling, which is the retrieval of the line with all the potential fish captured. So to collect data, accelerometers were attached to the hooks on the main line, as presented here on the figure, and the hydrophone were attached to the downline, usually one hydrophone per fishing area, monitored with accelerometer. And observers were present on deck to take notes about interaction, which were visible from the surface, but they were only present during the setting and during the hauling of it. For the data analysis, both types of data were first analyzed individually. So for the acoustics, I used Audacity to listen and analyze the first minute of each 5-minute window of the whole recording of each fishing operation monitored. And this minute was categorized as positive or negative detection minute, depending if we actually detected the presence of killer whales in the record. For the accelerometry data, I used EgoPro, and to visually analyze the variation in acceleration on the 3 axes. So the signal 1 that you can see here on the graphic was characteristic of a capture event. So it runs for quite a bit of time. And then for all capture events, we divided them into 3 categories. The first one was the catch. So if the fish was hauled on board. If the fish was lost during the fishing operation at some point, it was either identified or categorized as an unidentified events. And in case of evidence of a second signal with a depth variation, we categorize that as a suspected depredation. And the individual in that case was identified as a blue-eyed trevalla based on the killer whale selectivity that was reported in previous study by fishermen. Further analysis were done in R. So the very first results that we found showed significant differences between the detection rate made by visual observation compared to the detection rate made with acoustics. Observers detected the presence of killer whales in the fishing area in only 30% of the cases, compared to a 93% detection rate when using passive acoustic monitoring. So this could be explained either by non-optimal visibility conditions when the observers perform the observation, so that means bad weather conditions, but also maybe low lights, which makes sense because most, in southeastern Australia especially, but also in most of the longline fisheries, most of the operation are performed by night in order to avoid as much as possible the bycatch of seabirds. So it becomes really hard to detect killer whales in that case. And the second explanation could be the fact that most of the interaction actually occurred when the line was soaking on the seafloor, so when the observer was not on site to witness the interaction. In both cases, when the assessment of the interaction level relies only on surface observation, it is likely to be greatly underestimated. This figure shows you the variation in killer whale detection, acoustics detection for the first fishing season, so 2018-2019. It's presented by day, and I zoomed on one specific day, this day during which you can see for 3 sets monitored, we had 1 hydrophone deployed in the water, and you can see that as soon as the hydrophone reached the water, the presence of killer whales was detected in the area. So it's really early acoustic detection that could be explained either by the fact that killer whales were present in the fishing area way before the arrival of the vessel, or by the fact that they detected the vessel and then moved rapidly on site. This observation suggested that some areas where the fishers actually deploy their line might also represent a natural and valuable foraging area for killer whales. And in such areas, the competition between fishers and killer whales for blue-eyed trevalla might be greatly exacerbating. So that's something that needs to be taken into account before implementing further mitigation strategies. Regarding the occurrence of the capture events of the blue eyes, we wrote the first insight regarding the time and depth of captures You have here a figure that shows you the different proportion between the target species in blue and the bycatch species captured down the line over time from T0 here, the deployment of the line in the water. So what we saw is that on average, the blue eyes were caught later on the line, and that 93% of them, so almost all individuals, were captured when the line was soaking on the seafloor, apart from one individual which was captured during the study. We also showed that 50% of them were captured within the first 4 hours following the deployment of the line in the water. And this piece of information, combined with the negative influence of an increased soaking duration on the number of captures, all species included, which was shown in R, suggested that by limiting the soaking time, fishers will be able to enhance their profitability by targeting more the blue eyes, so the species that they want, and at the same time limiting the potential of depredation because they limit the time of access of killer whales on the line when it's soaking. Speaking of depredation, a total of 7 events were recorded in that study, and they were on average recorded to occur 3 hours following the capture of the blue eyes on the line, and to concern mostly blue eyes that were captured earlier and at a higher depth on the line. It was also the case that most of the captured blue eyes were depredated in fishing area where the killer whales were acoustically detected earlier compared to the others. These 7 suspected depredation events represent 50% of the blue eye total catch per unit effort, which is presented in this study in catch per hook. So that means that basically half of all the individuals that were caught during the fishing seasons were depredated by killer whales. So it is a great, a high depredation rate, which is likely to have substantial impacts on the blue eye trevalla stocks, because usually the depredated fish are not included as part of the total of the global catch during the fishing operation, which represent a major, which will might lead to wrong estimation of the quotas of captures in the future, which represent a major threat for the sustainability of stocks in that case, because that involves higher risks of depletion. It's mostly beneficial impacts on the killer whales population, because they will have access to an increased artificial food supply with more food resource available, which enable them to get a higher survival and fecundity rate. So that will probably change their ecology, but in a bad way. The question that remains, and which will let us know if it's really a great impact or if it's less impacting the blue eye trevalla, is to know if the species of fish is actually part of the natural diet of the killer whales. In this study, all the depredation events occurred at high depth while the line was soaking on seafloor, which when compared to other studies will suggest that killer whales are actually naturally foraging on blue eye trevalla, but we still don't know. In that case, even if we have a high depredation rate, it is less likely to impact the stocks. So in conclusion, this study provided information about the underwater occurrences of both fishing catches and killer whales interaction, which could be useful for fishermen, fishery managers, but also scientists who are investigating potential solutions to mitigate the conflicts locally, but also in other fisheries. The findings suggested that by fishing faster, so by shortening the soaking time, fishers will be able to ensure the catch rate while limiting the depredation risks. But this will be an operational adaptation, which may obviously induce additional restriction for the local fishing industry. And that's why their implementation requires a long-term assessment of all costs and benefits involved in the process. The combination of acoustics and accelerometry data was proved to be an efficient, novel approach, but also hard to implement in real fishing conditions. And it requires further research to confirm the capture pattern suggested in that study. The overall amount of quantification of the overall amount of fish depredated, together with additional data about the killer whales demography and ecology in the area, will be a great first step to be able to actually properly define the impacts, the socio-ecological impacts of the conflicts in the area. That's for my references. Thank you all for your attention, and thank you in 10 seconds to my two supervisors, Paul Tixier and John Arnold, for giving me the opportunity to work on this amazing project and for their help throughout the process.
Thank you very much, Maureen. Very interesting.